but it all comes with practice. So reduced matrix. And again, this is our goal, right? When I give you a system of equations and you get the augmented matrix, our goal is to get a reduced matrix by doing that algorithm. That algorithm should spit out a reduced matrix for us. And so here's what a reduced matrix is, just so you know how to identify it. And again, I don't expect you to fully absorb what I'm about to write on the board immediately, but after spending some time with it, maybe it'll be a little more intelligible. So what's a reduced matrix? And this is so an augmented matrix is reduced, is what we're going to say, if it's coefficient matrix. So remember when I said coefficient matrix last time? That's all the stuff to the left of the bar. So I'm just talking about the stuff to the left of the bar, really. If it's coefficient matrix satisfies the following. So here are some conditions. If you check all these boxes that I'm about to mention here, you have all these conditions in your reduced matrix. Okay, so one, the first row, first column entry is a 1. So that upper left corner entry is a 1. Remember, that's like the first thing we do in that algorithm. So step 1 is make sure this happens. So that's our first step on the way to being a reduced matrix. Okay, number 2. What do I want to say here? Each column, or I guess I should put it this way. Each row, talk about rows. Each row should contain, let me put it this way. Each row. Each row will either contain a leading 1 or is all 0. So if your row, there's only 2 possibilities for the rows. They're either going to contain a leading 1 in them, or they're just going to be all zeros. If they contain a leading 1, then the stuff to the left of the 1 is 0 already, but the stuff to the right can kind of be anything. So it doesn't matter what's happening to the right if it has a leading 1. So the rows will either have a leading 1 in them, or they will just all be 0 in that row. So you can have rows that are entirely 0, and that's fine. That'll definitely happen. And then this next condition says the following: the leading 1s I'm going to use this word descend to the right. And I'm going to write some examples up here just to make this extra clear what I mean. But so the leading 1s are going to sort of go down to the right. If I move to the right, the leading 1s should shift down by rows as we count them. Okay. So I think I got all that I need up here for reduced matrix. I think this should cover it with our definition of leading 1. Again, this doesn't say anything that's happening to the right of the bar. This is all just stuff to the left of the bar in my augmented matrix, or as I might say, the coefficient matrix. Okay. So let me just put a couple examples and non-examples on the board, just to show what these really, some more examples of what these look like to get it some intuition. So first row, first column's a 1. Each row is either a leading 1 or has all zeros, and the leading 1s have to descend to the right. Okay. So here's some examples. Here are some reduced things. Of course, something like this is reduced because I have my leading 1, leading 1, leading 1. Each row has a leading 1 in it. And when I look, like I said, the leading ones sort of go down as I go to the right. So they go down this sort of like staircase fashion, what you might hear. Leading ones shift down. So this is reduced. Here's another reduced thing. Here's another matrix. This one is also reduced. I'll show you the leading ones are all here. Here's a leading one. Here's a leading one here. Oh, sorry. Let's make this a 0. That was not reduced. Let's make that a 0. Now it's reduced. I have 2 leading ones in this matrix. That's what I meant to write up there. This is now a reduced matrix. I have these 2 leading ones. So I have a row here that has a leading one. This row has a leading one. And this row is all zeros to the left of the bar, of course. This row is all zeros. Yeah. Now, it's going to end up being a problem that this is 0 equals -2. We'll see in a minute later on that this means there's no solutions. But for now, this is reduced. This is a leading one. This is leading one because it has zeros. And that's it. This is reduced. The leading ones go down as I go to the right. Shift down by a row. So let me give you something that's not reduced. Here's an example of something that's not reduced. Why is this not reduced? Well, this is not reduced because this 1 down here is not a leading 1. There's a 3 in its column. That 3 would need to be a 0 for this to be reduced. And so this cannot be reduced because this row does not have a leading 1 in it. So this is not reduced. So I'm going to separate these. These are reduced. This is not reduced. I'm going to give you one more example of something that's not reduced. This will be a sort of sillier example here. Instead, my matrix looked like this. This is also not reduced because this is not a 1. This would need to be a 1 so that it would then be a leading 1. Yeah. Okay. So there's a couple examples of reduced or not reduced matrices. So we want reduced because if they're reduced, it sort of tells me the answer right away to my system of equations. If it's not reduced, I'm not there yet. I don't know a solution. This one seems like maybe it's harder to find a solution for it because I have these other numbers floating around. But we'll talk about that probably tomorrow or maybe on Wednesday about exactly how to interpret that in terms of the system of equations. So, okay, good time to stop again for questions if there are any. So I think I've said what I pretty much wanted to say today. And hey, look, it almost took the whole class period, which is fine. It always takes a long time to introduce all the matrix stuff. But so did anyone have any questions? Is feeling okay with this stuff? Okay. Well, if there are no questions, let me just tell you. Yeah, with 4 minutes left, I'm probably not going to do another example on the board because I just don't have enough time. And not really a meaningful amount of time for me to, for us to supervise activities in your groups. So we'll probably just call it a day a little early today. But I'll just point out that I have uploaded the first activity for 5.3 already. So that's on Canvas, 5.3a. You might take a look at that and start getting you some practice in solving these. We can spend some time on that in class tomorrow. But then probably we'll shift gears at some point tomorrow during class, and I will tell you a little bit more about like matrices with no solutions or with infinitely many solutions and how to deal with those, and maybe see a couple more examples. And there'll be another activity coming. I'll probably upload it tomorrow, just so you're aware. But otherwise, if you guys don't have any questions for me, you are free to go. Of course, I'll stick around if you want to ask questions. But otherwise, you guys have a good day.